This study asks whether a single probiotic strain can improve polycystic ovary syndrome through a defined mechanism. BGI-L99 reshapes the gut microbiota and bile acid profile, increases IL-22 signaling, and its key effects can be reproduced by CDCA or TUDCA supplementation. Polycystic ovary syndrome mainly affects women of reproductive age and is often accompanied by reproductive, metabolic, and emotional problems. Current treatments still have limitations, and the specific mechanism of a single probiotic strain remains unclear. The study first analyzed public population data and found higher BGI-L99 abundance in healthy subjects. The study built a DHEA-induced mouse model of polycystic ovary syndrome with 21-day BGI-L99 treatment, then added CDCA and TUDCA separately to verify bile acids' therapeutic functions. The DHEA model showed disrupted estrous cycles, fewer corpora lutea, more cystic follicles, and elevated testosterone levels. BGI-L99 reversed these changes and regulated E2 and T levels, indicating that its effects were not limited to body weight, but also improved ovarian and reproductive endocrine function. Metagenomic data revealed distinct microbial functional patterns in mice with polycystic ovary syndrome, which normalized after BGI-L99 treatment. Beneficial bacteria rose, while opportunistic pathogens declined, with metabolic shifts focused on fatty acid, bile acid, and short-chain fatty acid pathways. Short-chain fatty acids, including acetate, butyrate, and isobutyrate, were reduced in mice with polycystic ovary syndrome, but recovered after BGI-L99 treatment. CDCA and TUDCA levels also increased markedly, providing an important link to the subsequent changes in immune signaling. BGI-L99 upregulated intestinal TGR5 and GATA3, elevated tissue and serum levels of IL-22 and IL-10, and inhibited TNF-alpha, indicating that it relieves inflammation and ovarian dysfunction via bile acid-dependent pathways. Microbial network analysis proved BGI-L99 stabilizes disordered flora as a core cross-feeding hub. Virtual deletion of this strain reduced overall community metabolic flux by 36.7%. Supplementation with either CDCA or TUDCA alone restored estrous cycling, reduced cystic follicles, increased corpora lutea, and improved endocrine markers. Both treatments also increased IL-22, TGR5, and GATA3, indicating that the bile acid-IL-22 axis is a functional mechanism rather than a bystander effect. Overall, BGI-L99 remodels the gut microbiota, restores CDCA and TUDCA, and activates the TGR5-GATA-3-IL-22 pathway. This leads to improvements in ovarian morphology, estrous cycling, hormones, and other polycystic ovary syndrome phenotypes. The study constructed a clear BGI-L99 bile acid-IL-22 mechanistic axis, combining multi-omics, ovarian pathology, and supplementation assays to support targeted probiotic and bioacid therapy for polycystic ovary syndrome. The study still has limitations. The DHEA model cannot fully represent human polycystic ovary syndrome. Pathway necessity requires knockout models. Bacterial BSH activity needs direct testing, and clinical dose, duration, efficacy, and safety remain to be confirmed. BGI-L99 improves reproductive, endocrine, and metabolic abnormalities in mice with polycystic ovary syndrome. Its core mechanism is to remodel the gut microbiota, restore key bile acids, and activate the TGR5-GATA-3-IL-22 axis. This study provides new experimental evidence for mechanism-guided probiotic interventions.